Hello students, welcome to Easy BTech, your guide for BTech and beyond. In the today's lecture, we will discuss about instability of collector current. Instability of the collector current. How the collector current will be unstable, that we will discuss. In a transistor circuit, in a instability of the collector current. Instability of the collector current. First, in a transistor circuit, collector current is varying on its own. Collector current is varying on its own. Okay. Collector current is unstable because of changes occurs in IC due to various factors. That is, we know that collector current equation IC is equal to beta IB plus 1 plus beta IC naught. Okay, IC is the collector current, IC is the collector current, IB is the base current, beta is the current gain, IC naught is the reverse saturation current. Okay, IC, it is a standard current equation. Now IC now. IC changes with respect to IC naught. You can say that as temperature increases by 10 degrees centigrade, its reverse saturation current or minority current will will be doubled per 1 degree rise in temperature, reverse saturation current increases by 7%. It means as temperature increases, IC naught increases. IC naught increases, IC increases. Okay, due to temperature, IC is unstable. This is IC is unstable due to temperature. Next, VBE. As temperature increases, as temperature increases, as temperature increases, what happens? VBE decreases by minus 2.5 millivolts. Okay, per 1 degree rise in temperature, cut in voltage decreases by minus 2.5 millivolts. Now we see this graph. This is IB, this is VBE for common emitter configuration. Now this is a graph. It means this is VBE. As the cut-in voltage shifts to the left side, shifting left side, it means as VBE changes, definitely IB changes. Okay, as VBE changes due to temperature, as VBE changes due to temperature, IB changes. IB changes. As IB changes, IC changes. Okay. Collector current is unstable due to IB and VBE changes. Okay, and beta. As transistor is replaced by another device, it is another transistor is replaced by another transistor, then the value of beta changes, and the value of beta changes, which may cause to change in beta, which may cause to change in IC. Now IC becomes unstable, or we simply say unstable. That is stability factor change in IC with respect to change in IC naught. Change in IC with respect to change in VBE. Change in IC with respect to change in beta. This is defined up as a stability factor. Change in IC with respect to IC naught. Change in, you can see the equation, IC is equal to beta IB plus 1 plus beta IC naught. We can see IC changes with respect to beta changes. IC changes with respect to IB changes. IC changes with respect to IC naught changes. That is why IC is unstable due to beta VBE IB and IC naught. These parameters makes the collector current unstable. These parameters makes the collector current unstable. Okay, as collector current is unstable, first point, operating point will shift. Operating point will shift. Operating point will shift. Next, transistor moves from one region to another region. One region to another region. One region to another region. Third, operating point will shift. Transistors moves from one region to another region. Next, you can see as IC current going on increase, thermal runaway takes place. Thermal runaway takes place. Thermal runaway takes place. Due to which collector current rises. Due to which collector current rises. The transistor gets damaged completely or permanently. Okay, students, this all are the effect of the collector current. As the collector current increases, the transistor is completely get damages. What makes to increase the collector current? Reverse saturation current, VBE and beta. These three parameters will changes the collector current to unstable. Okay, as this collector current becomes unstable, operating point will shift. The transistor moves from off region to on region, that is one region to other region. It may move from active to cutoff or cutoff to saturation or saturation to active, like that. The movement of region in the transistor takes place. Okay, we will find the stability factor. That is, what is the stability factor? Change in IC by change in IC naught. This we know as the stability factor. We know that IC is equal to beta IB plus 1 plus beta IC naught is an equation. Differentiate equation 1. Okay, differentiate. We'll write change in IC beta IB beta change dou IB plus 1 plus beta change in IC naught. Now you can divide this equation to divide equation 2 by change in IC. Now what you will get? Dou IC by dou IC is equal to beta dou IB by dou IC plus 1 plus beta dou IC naught by dou IC. Okay, this is equation 3. Okay, from equation 3 this will cancel and it will become 1. Dou IC by IC1 is equal to beta dou IB by dou IC plus 1 plus beta dou IC naught by dou IC. Now if it will move this side, becomes 1 minus beta dou IB by dou IC is equal to 1 plus beta dou IC naught by dou IC. From this we'll explain dou IC naught by dou IC is equal to 1 minus beta dou IB by dou IC by 1 plus beta. Okay, we know that the stability factor change in IC naught by change in IC. Change in IC by change in IC naught. Now reverse for this. This will write dou IC by dou IC naught is equal to 1 plus beta by 1 minus beta change in IB by change in IC. Stability factor is equal to 1 plus beta by 1 minus beta change in IB by change in IC. This is the stability factor. Stability factor. Okay, students, in this today's lecture, we discuss about instability of the collector current, how the collector current will be unstable, and how the collector current will move from one region to other region, and we have derived the stability factor. We have derived the stability factor. What is the stability factor? Change in IC with respect to IC naught, means collector current changes with respect to the reverse saturation current or leakage current or minority current, or change in IC with respect to the beta. As the beta value gets changes, as beta value gets changes, definitely collector current may changes. Okay, you can remember in mind, as temperature increases, IC naught increases. As IC naught increases, IC increases. As temperature increases, VBE increases. As VBE increases, definitely IB increases. As IB increases, and definitely IC collector current will increase. Okay, these are the factors which will influence and the changes can occur in the collector current. Okay students, I hope you may go through this. Easy BTech, guide for BTech and beyond. Thank you.